This week we're looking at inventory management. So inventory is any idle material or product that is in a warehouse or storeroom. So this can be your raw materials. This can also be your work in process if it is sitting in between areas where it's being produced. So what we're going to look at is different types of inventory management. And that type of inventory management depends on whether you have what we call independent or dependent demand. And we looked at this in a previous video. So independent demand is where, excuse me, the demand for your product is fairly stable. So if you're working directly with a customer, then you probably have independent demand. Okay, so you can forecast how much they're going to want and you can plan accordingly. So the key questions are how much do you order and how often do you place those orders? We're going to look at different inventory management systems within independent demand. We're going to look at fixed order quantity, fixed order interval, and single period model. Now it's also likely that you have dependent demand. That is that you aren't working directly with the customer, but that what you're making is going into some other product, in which case the demand is more lumpy. So if you have sub-assemblies, you make a component and that component goes into something else, then it's a sub-assembly. And so the question then is how much do you make and how much extra or excess do you make in addition to the expected demand? So how much safety stock do you create? And then we look at, is it a push system or a pull system? So if we're making sub-assemblies, do we make those components and then push them to the area where we're making the final product? Or do we have a pull system? That is, making of the final product will pull the items that are made elsewhere just as they are needed. So we're going to look at just-in-time manufacturing as well as material requirement planning. So material requirement planning is a push system, just-in-time is a pull system. So let's start by looking at independent demand. When we have independent demand, we can manage our inventory in 3 different ways: fixed order quantity, fixed order interval, or single period model. So let's start with the first one, which looks at, missing my little pens. Come on, pens. There we go. All right. So with fixed order quantity, we're looking at ordering. So we're going to order when the amount on hand drops below a reorder point. So with fixed order quantity, the idea is that we order the same amount every time, and so we just need to figure out when we're going to be placing those orders and how much that quantity is going to be every time. And ideally, we'd like that quantity to be the economic order quantity. Economic order quantity is going to be the order size that minimizes the total inventory costs. Okay, this is total inventory control costs because it doesn't actually include the price of the inventory. What we do include in this is the cost to order the inventory and the cost to hold the inventory. So fixed order quantity, we're going to order a fixed quantity and we just need to figure out when that's going to be and how much that quantity is. Fixed order interval in comparison is when you place an order at the same time. So maybe you place your order every Tuesday, or maybe you place your order every third week. So fixed order interval is a fixed time, fixed order quantity is a fixed amount. So let's look in more detail at fixed order quantity. We said that we want to set the reorder point to economic order quantity, to an order size that minimizes our total costs. So we need to look at those costs. Let's just create a blank page here. And let's look at what inventory costs we have. So the first inventory cost we want to look at is that of holding cost. This is also called inventory carrying cost. So this would include the cost to store your inventory and its obsolescence cost. So if it's losing value, if we can no longer use it over time, that would be included as well. So the holding cost is the cost to keep an item in inventory. Okay, now what happens to the holding cost? So if we drew a graph and we looked at the size of our orders versus the cost. So what happens to the holding cost, whether you have lots of small orders or whether you have one big one? Well, if the holding cost is the cost to keep an item in your inventory, then if you ordered one big shipment, then you would have to hang on to all that inventory as time passed for you to use it all down. So if you had one big shipment, we'd have a high holding cost. If we had lots of small shipments, then we wouldn't have to store it. We'd use it up quite quickly, and the new ones would arrive, so the holding cost would be low. So when it comes to holding cost, big shipments are costing us more than small shipments. Now we have another inventory cost we have to consider, and that is ordering cost, also called shipping cost. Your ordering cost or shipping cost is the cost to place an order, not including the purchase price. So we're going to place the order, we're going to receive the order, and any of the processing for payment. So place an order, receive it, and pay for it. Okay, so when we think about our ordering costs or our shipping costs, what happens to those costs if you have small orders versus big orders? Okay, so if we have lots of small orders, then we have to place a lot of orders and we have to pay for shipping every time. So if we have lots of small orders, the cost is going to be high. If we have one big order or we order lots, then that's less of an ordering cost because you're paying for shipping once. So if we graph the ordering cost, you'll notice that the cost decreases the bigger the order you place. Well, when we look at EOQ then, EOQ, the economic order quantity, that's going to be the quantity that minimizes both your holding cost and your ordering cost. So what we're looking for is that quantity somewhere between our many small orders and our one big large order, where we are minimizing the total of both the holding cost and the ordering cost together. So let's look at how we find EOQ and how we decide how much quantity to order. As we do that, let's go back to our slides here. We need to recognize that the fixed order quantity method has a number of assumptions. Remember that fixed order quantity goes with independent demand. So we're assuming that demand is known and fairly stable, okay? So consistent, doesn't change a whole lot over time. We also need lead time to not vary. Lead time is the time between placing an order and receiving it. So if every time you place an order, it takes 2 business days for your order to arrive, we need that lead time between order and when you receive it to not change a whole lot. And the reason is that we have to recognize that there is a cost, right? Every time we ship our inventory, that has a cost, and it costs to hold the inventory as well. Well, when we are ordering our inventory, we're going to need to make sure that we have enough inventory on hand during that lead time between when we place the order and when the order arrives. So that lead time can't change a whole lot. We're also going to assume that we can't buy in bulk. Otherwise, that would change the quantity we would order. So if there's no quantity discounts, we can simply go with the quantity that will minimize the ordering costs and the holding costs. Let's also assume that shortages are not allowed. So we're going to need to make sure we have sufficient amount of inventory on hand for what we need. And orders are received in a single delivery. So if you place an order for a specific quantity, then it arrives in the quantity you ordered, not piecemealed out over time. Okay, so we need these assumptions to exist in order to determine the quantity that minimizes our inventory costs. All right, so let's take a look at how we would do a calculation like this. Well, let's start with a scenario where we already have the order size. So before we get to EOQ, let's suppose that we already know the order quantity. So let's suppose that our order quantity is 350 units. So every time we place an order, we order 350. Okay, so quantity equals 350. And let's assume that when we place an order, so you place an order on day 0, okay, or sorry, my apologies. Let's say that we receive an order on day 0. Okay, so we receive the full 350. And by day 7, we're completely out. So it takes 7 days to go through that entire quantity that we received in that order. Now, also note that our lead time, that's the time between when we place the order and receive the order. Here, our lead time is 2 days. So if our lead time is 2 days, then we need to recognize that we're going to need enough inventory on hand so that when we place the order, we can keep using that inventory and that we'll have enough for the 2 days it will take between when we place the order and receive the order. So if we're using down those 350 units, we need to make sure that when we reorder, we have enough for the 2 remaining days. Okay, so the reorder point, let's change that here. The reorder point is equal to your demand rate times your lead time. And we always need to make sure that the measurements are all in the same type of units. So our demand rate is in days here, and our lead time is in days. So we said it's going to take 2 days between when we place the order and when the order arrives. If our quantity that we're ordering is 350 units, and we use that whole thing up in 7 days, we need to figure out our demand rate. So how many units are we using up per day? So that 7 is because when we received the order to when we run out, that was 7 days, and the quantity that we received was 350. So 350 divided by 7 says that we're using up how much inventory per day? Well, 350 divided by 7 is 50. So our demand rate is 50 units per day, and our lead time was 2 days. So when do we need to place the order for our inventory? Well, we're going to need to place that order 2 days before we run out. And our reorder point, well, if we're using up 50 units a day, we need to place our order when we are down to 100 units. Okay. All right, well, in that case, we have the order quantity. So while we have an order quantity given to us, let's also look at the cost associated with ordering that quantity. So let's take our order quantity. Just make a little list here. Okay, our order quantity was 350, and our demand rate was 50 units per day, because we're using up all 350 within 7 days. Our lead time was 2 days. Now, let's look at some costs. So let's assume that our holding or carrying cost is $5.10 per unit per year. So for every unit that sits in a warehouse, it's costing us $5.10 per unit for the year to sit there. So maybe we have, excuse me, a storage fees or fees to pay for that warehouse. We also have a shipping cost or an ordering cost. That shipping or ordering cost is per order. So every time we submit an order to our supplier, it's costing us $8.70 an order. Well, once we know this information, we can then figure out how much an order of 350 is costing us. Okay, so what we're going to do is we're going to calculate annual holding costs and annual ordering costs. So here's the formulas we need. And in this case, the holding costs and the ordering costs, if we're going to do them in annual terms, then we need to make sure that our holding or carrying cost that we're given is also in annual terms, which it is. And our shipping cost, it's going to be per order, so we don't have to worry about that. But we do need the demand to be in units per year. So these need to match. If we were instead calculating weekly holding costs, then our holding costs would need to be units per week, and our demand would need to be in units per week. So we need to make sure they match. In this case, we're going to do it for the year. All right, so let's take our information and figure out how much it costs us for us to basically order 350 units each time we place an order. Okay, so let's do our calculation here. I'm actually just going to create an empty blank page so we have a place to write. So let's just clean this up a bit. So quantity 350. Our demand was 50 units per day. And what else did we have? We had a lead time of 2 days. We had a holding cost of $5.10 per unit per day, per unit per year. And a shipping cost of $8.70 per order. So our annual holding cost is equal to quantity, so the amount of order we place. All right, and then we're going to divide that by 2 and multiply that times our holding or carrying cost. So these formulas, others have derived. We simply need to use them. So we'll take our 350 unit order, divide it by 2, and multiply by our $5.10 per unit, right? 350 is units, okay, per year. So we're in years, it says annual here, and we're in our same units, so we don't have to do any conversion. So we take 350 divided by 2 times $5.10, and our annual holding cost then is $892.50. All right, what about our annual ordering cost? The formula for annual ordering cost is your demand divided by your quantity, your order size, times the shipping cost. All right, so let's check our units here. Our demand is in 50 units per day. Okay, well, the problem is this is annual ordering cost. So we need to convert our demand from 50 units per day to annual demand. Okay, so here we take 50 units per day times the number of days in a year. Now, if our company doesn't work 365 days a year, maybe we only work 200 days a year, then you're going to have to convert or use that number. So in this case, it doesn't specify, so we'll assume we're always working. 365 for our 50 units per day times 365 days in a year. Okay. So that gives us our demand. And we need to divide that by the order quantity. So that's 350. It's in units. Our 50 is in units, so we're good there. And lastly, we need to multiply by our ordering cost, which is per order. So that's $8.70. Okay. So the annual ordering cost, 50 times 365 divided by our 350. So let's calculate this out. 50 times 365 divided by 350 times our $8.07. And we get that the annual ordering cost is $453.64. So we could add the two of these together, and that would be the total inventory cost. So these costs, though, are based on an order size of 350 units. We want to find the order size that minimizes both the holding cost and the ordering cost. So we want to figure out what quantity that is that minimizes the two combined, right? So if these are our total costs, we want to know the quantity that minimizes them combined. And this quantity isn't necessarily it. To find that EOQ, that quantity that minimizes the total inventory costs, we have a formula for that. So if you are not given an order size, if you don't already know the size of the orders, you can figure out for your company what the optimal order size is that minimizes the total inventory costs. So in that case, let's just go here. Okay. We're going to use this formula here, this EOQ formula. So EOQ is equal to the square root of 2 times the demand times the shipping cost divided by the holding cost. Let's go back to our blank page here. All right, so EOQ was equal to the square root of 2 times DS divided by H. All right, so we're going to need to know our demand. Well, we know our demand per day, right, is 50 units per day. We know that our holding cost was $5.10 per unit per year. And we know that our shipping cost is $8.70 per order. So we can determine the quantity that minimizes our total inventory costs. All right, the key here is that everything needs to be in the same number of units. So notice here that demand is in 50 units per day, and our holding cost is per year. So we're going to need to do a conversion in our formula. So the square root of 2, and then we're going to need demand in per year terms. So 50 units times the 365 days in a year times our shipping cost of $8.70 per order divided by our holding cost, which is $5.10 per unit per year. Okay. So we plug that information in, we do our calculation, and we find that the quantity that minimizes inventory cost is 250 units. So instead of ordering 350 units, we can minimize our inventory carrying cost and our inventory ordering cost by ordering 250 units. The other thing we want to be able to calculate is what is called the length of order cycle. The length of order cycle let's go back to our sheet here. The length of order cycle, if you want it in years, is your EOQ divided by your annual demand. Okay. So if we do our length of order cycle calculation here, let's go back to our page. Okay. We take our EOQ divided by demand. If you want your length of order cycle to be annual, then the demand here is going to have to be annual. So we take 250 and we would need to divide it by annual demand, which is 50 times 365. If you want your length of order cycle to not be annual, but instead be days, then we're going to need our demand to be per day. So we need them to match. So if we make it demand per day, and we take 50 per day, then what that tells us is that the length of order cycle, so between each time that we order, how much time has passed between when we place one order and when we place the next order, it's 5 days. Okay, so we're going to place an order every 5 days. Now, what happens to your EOQ if there's a change in the holding cost or in the shipping cost? So let's create one more blank page here. And let's rewrite out our formula once more. So EOQ is equal to the square root of 2 times your demand times your shipping cost divided by your holding cost. All right, so what happens if holding costs go up? What if it costs more to store your inventory in your warehouses, to hold on to it? Well, if you have to pay more to hold on to it, what should happen to the size of your orders? Well, we can look at it mathematically. If in our formula, EOQ equals 2DS divided by H, if the number on the bottom of our formula increases, we're now dividing by a bigger number. So if you divide by a bigger number, what happens to the total number you're calculating? Well, it makes the whole economic order quantity go down. And this should make sense, because if it's costing you more to hold the inventory, it's better to have smaller, more frequent deliveries. You'd rather not hold it because it's costing you more, so you might as well have it arrive when you need it. Now, what if shipping costs go up? From a mathematical perspective, EOQ equals 2DS divided by H, we are now increasing a number on the top of the formula. So if you're increasing a number on the top of the formula, then you're now multiplying by a bigger number. So what's going to happen to our total quantity? EOQ will go up. And this should make sense because if the shipping costs increase, then you're not going to want to place as many orders. So you're going to place much larger orders and less often. Why pay the extra shipping cost? Instead, order lots all at once so you don't have to have multiple shipments. Now, if you have a order quantity that is not EOQ, let's go back to our actual slide here. If you have an order quantity that's not EOQ, you can still do the length of order cycle calculation. You're just going to use your quantity measurement instead of EOQ. But if you want to find the quantity that minimizes your costs, then you want to do our EOQ calculation here and figure out the quantity that takes into consideration that if you have small, frequent batches, your ordering costs are going to be higher. And if you have one big order, your holding costs are going to be higher. So it's the quantity that minimizes the combination of the two.